Hello everyone, welcome to Pathshala. Till now, we have learned we can use convolutional neural network for an image. So, can we use convolutional neural network for text classification tasks like sentiment analysis? Yes. How? Let's see in this video. We know that convolutional neural network in TensorFlow is made up of Conv2D layers. Every Conv2D layer includes filters of different size. For example, filters might be 3 by 3 filters, 2 by 2 filters, or 5 by 5 filters. These filters will convolute over the image in horizontal direction and vertical direction. That's why the name is 2D, Conv2D. Okay, now let's try to understand how we can use convolutional neural network for the text. We know that we cannot work with the raw text. We have to convert each component, that is either word or character or the sentence, in a vector. Okay, let's try to understand how to represent a paragraph in a matrix with the help of words. Okay, so suppose we are going to consider 1,000 words. So the number of rows will be thousands and each word is represented by a vector of size 300. So the matrix size will be 1000 by 300. 1000 unique words are there and 3000 is the dimension for each vector. So we have a matrix of size 1000 comma 300. Now over this matrix we are going to convolute a filter, but the filter size will be the size of each word vector. Okay, so we are going to form a filter which will occupy a complete size of the word. Okay, now filter size might be 2 by 300 and this filter will convolute over the image in only one direction. So in the next timestamp the new position for this filter will be something like this. In the next timestamp, new filter position will be something like this, provided that stride is 1. Okay, and likewise it will continue. That's why the name is Conv1D. Okay, so the filters are going to convolute in only one direction. Okay, so we are going to use this Conv1D layer in TensorFlow models to work with the text because it is occupying the complete vector size for the convolution, and it makes a sense. If we are not assuring that filter is not going to hold the complete vector size, then again filters will convolute in both these direction and words will be split in different ways. It doesn't make any sense, so we have to use Conv1D layer. So let's see Google Colab notebook how to use this in sentiment analysis. Okay, in the first cell we have imported all the required libraries. We have imported TensorFlow as TF. Then we have imported all the layers and models available under TensorFlow.keras. And finally, we have imported IMDB module present inside TensorFlow.keras.dataset. One of the beautiful thing is TensorFlow.keras has pre-packed IMDB dataset. We have to use load underscore data method to get that IMDB dataset from the Google storage. We have little bit configured this load data with num underscore words is equal to 1000, means we are going to consider top 1000 frequently used words from the IMDB dataset. It will return train underscore x, train underscore y for training, and test underscore x, test underscore y tuple for the testing. If we print the fifth review from the training, then we are getting series of numbers. So these numbers are going to represent the corresponding words. We know that raw data need to be converted into a vector. So for that, tokenization has to be applied. After tokenization, number will be assigned with each word through a vocabulary, and each word or each number has associated with a vector representing that word. So tokenization and assigning number to each word from the index that has been done by the IMDB. That's why if we are printing fifth review, we are getting series of numbers. So the label associated with the fifth review is 0. So it is indicating this review is -1. But what these numbers are, let's check out those. So for getting the vocabulary, we have to use get underscore word underscore index method from the IMDB module. So this will provide us the vocabulary, complete vocabulary associated with the IMDB dataset. We are using top 1000 words. When we are dealing with the text, we have to make sure that each review is of same length. Some of the reviews are smaller, some of the reviews are larger. So in order to have the input of same size, we have to pad the smaller reviews to make the length equal to the largest review. So that can be easily done with the help of sequence available under keras.preprocessing. Max word is equal to 500 means we are going to use 500 words in each review. If reviews are shorter, then we are going to pad those reviews with 0. So that can be easily done with the help of pad underscore sequence. So this method is going to take the original training X and maximum length we have considered. Same is true for text underscore X also. Now let's define our model. So we have specified our model is sequential one. It indicates layers are stacked one after another. Output of one layer will be provided as input to the next. So first layer is embedding layer. In embedding layer, we have specified we are dealing with 1000 unique words. Each word will have a vector of size 300. Input length is equal to max underscore words, that is 500. Job of embedding layer is to form the word embeddings for 1000 unique words of size 300. So input to the Conv1D layer will be a matrix. Here in Conv1D layer we are using filter of size 3. Likewise, we are using 64 filters with activation function as ReLU. We can use filter size is equal to 2, 3, 5, 7, so on. Length of that filter will be 300 since we are using Conv1D. Now if we are using filter size is equal to 2, then we are considering pairs present inside the input text. Sometimes it is also called as bigram. If we are considering 3 words, we are considering 3 words combination. This is also called as trigram. After that, we are using max pooling 1D layer. It is just considering 2 by 2 subparts of the featured map, and it is just identifying the maximum value out of it. So important features are transformed from first layer to the next layer. Next we have again used Conv1D layer with size 3, and now this time we have used 32 filters. After that again we have used max pooling 1D layer with size 2 by 2, and output of this will be provided as a input to the next dense layer where we have included 8 neurons with activation function as reru. And ultimately at the last we have again the output layer where we have used only one neuron with activation function as sigmoid. Only one neuron is sufficient to identify whether a given piece of text is positive or negative. Then we have compiled our model and we have specified how our model will be trained. We are using loss as binary cross entropy, optimizer as Adam, and matrix is equal to accuracy. Then we have printed our model with model.summary. So in summary, we will get a table with the layer name, what will be the output shape and number of the parameters learnable over there. After compiling our model, we have trained our model with model.fit. So we have passed train underscore x, train underscore y. We have provided batch size is equal to 128 and validation split is equal to zero point 0.2, means 20% data is used for validation. After training, accuracy is close to 57% and validation accuracy is close to 55%. These are the graphs that we have received for training and validation accuracy and training and validation loss. So if we consider output is not that much good compared to the simple RNN, LSTM and GRU. These are the models which can be used to consider the sequence of words where the convolutional neural network is going to concentrate on local data. So in order to have more accurate result, we can combine CNN and the sequential models like LSTM or GRU. So CNN will concentrate on local data and LSTM or GRU will concentrate on global data. So the combination of these two will improve the result. Thank you for watching the video.